We are going to discuss the introduction about DevOps, what are the market trends, how it came into the software engineering in the IT field. So, to begin with, let me introduce myself. I'm Devyanshu Mehta. I'm working in as a DevOps engineer in IT field for around 4 years now, and I have worked on around 7 to 8 projects, live DevOps projects, which I have been working on. So yeah, so DevOps, to begin with, first let's talk about how DevOps comes into the picture before what are the software which we are using before DevOps. So before DevOps, there is a term called software development lifecycle. So what it means that to to make a software to have a software, you need to have some development lifecycle for a software. So for that, you like there are different models in the software development lifecycle. Like you must be reading that waterfall model, spiral model. So these are the uh, models which companies used to follow so as to have the product in the more effective way. So this is how software industry works before with this model, with these models. So there are some redundancy, there are some flaw in these all models, like waterfall and spiral. So that's why there is a huge need of the DevOps term or DevOps profile. So uh, I- I'll I'll explain you how the SDLC works in brief. So these are the like all the models work on this flow only, but the structure is different for each and every model. So how SDLC works is, first we used to gather the requirement, what is required from the clients. Like clients give you the requirement, we gather all the we gather all the requirements, gather all these things in the documents, like all the information, creates the work items, like create the stories, or you can say create the task which developers and QAs needs to do. First thing, this is the requirement gathering. Then once we have that, we'll create the design for that, like how the UI will look. At broader level, if you talk about it, we create the architect of that product. Okay, once we have that design and all the requirements, we'll just implement that. Mean we just code it, test it, we just code and test. So after doing that, after having after having the product, whether it's be a web product or whether it's a desktop app, any kind of product, once we have written all the code, testing and everything, we just deploy the code because it's ready to ship to the production or any environment. We'll do that, then we'll deploy, and in the end we'll do the maintenance. So this cycle is for one environment. Let's say it's for a dev. Likewise, if you see that there is a cycle with the requirement analysis to the maintenance. So we have to follow the same process for each and every environment. Let's say we have four: dev, QA, UAT, and production. So why we have these four environments? Like we cannot push the code directly to the directly to the production. So that's why we are having three different stages before going to the production. So every time we need to follow these steps. Like in this scenario, what the flaw is, like the requirement, every time the requirement changes for the customer, like clients used to say that no, we want this feature, we want this feature. So every time there is a lot of hurdles in these, in following these steps. So, and also there are a lot of gaps between the developers, QAs, IT, and infrastructure guys to how to launch the code. Because see, developer knows how to code, QA knows how to test that code, and IT guys knows how to set up the architecture. So developers don't know how to have the like how to set up the environment. They don't know about that. They know there are a lot of complication if you are an operation guy or IT infrastructure guy. So there are a lot of complication, like this .NET stack or this .NET code will be compatible with this framework. So there are a lot of complication behind that. And say likewise, the IT guy don't know that what are the things developer has written in their code, whether it's be a Java code, .NET code. He don't know about that, the infrastructure guy. So there is a lot of gap in this. If you're seeing dev, QA, and IT infrastructure guys, so there is a lot of gap in this. So that's why there's a need in IT. There's a need for a new profile, or you can say for a new culture. So that's why DevOps comes into the picture. So if we talk about what is DevOps, if you talk about, there is a combination of two terms, dev and ops, meaning development plus operations. So to reduce the gap between all these departments, developers, QAs, and your IT infrastructure guys, there's a new guy who is known as DevOps engineer, who will be having all the information related to the development, related to the QA, and related to the infrastructure level. So he just reduces the gap. So if you see in the picture, there are development and tester, which is now like these developers and testers usually isolated from the IT operations guy. They don't, both the teams don't know how both works. So this plus sign, in the plus sign we can add the DevOps, which is reducing the gap between the developers, testers, and the IT operations. So this is how DevOps works. So I'll show you, like, let's briefly talk about what is DevOps in little detail. So as I told you earlier, DevOps is nothing but the combination of development and operations to reduce the gap. So it is improving the operations as well as the development. So as a DevOps guy, I should be knowing how how the code is. Like it's a Java stack. I need not to do how to write the code or like what is in the code. But yeah, basics I should be knowing it. Like this is this framework. This is Java code or a .NET code. That's it. How the code will compile, that I will be knowing. And the next part, if you talk about the operations, I should be knowing that what kind of hardware it will be needing for that to deploy that code into that server, and what are the compatible, like some websites need some framework compatibility, how that compatibility will be suitable for that server, I'll be knowing that. So this is how it improves the dev and the operations. Like I said in the third point, it reduces the gap between dev, QA, operations, and IT teams. So DevOps is like a 24 into 7 job in which you will be knowing each and everything, but not in detail. But yeah, you will be responsible for releasing the code to every environment, and you will be responsible for like uh, pushing the code to the live environment in an effective way, without any without any errors and all. So earlier what happened is, like when there was no DevOps introduced in 2009, it boomed in 2003, oh sorry, 2013. So earlier when there was no DevOps, so developer has to take care of the releasing the code. He first has to write the code, then the IT guys give the server, then he has to somehow write some PowerShell scripts to deploy the code from one and to his machine to the live environment. So there are a lot of complication. Like he has to write the code, he only has to deploy the code, and he will be responsible if there is any error. So IT guys and operation guys, they just give the server. He will say that I'll be needing a 8 GB RAM and 500 GB memory and two servers and with a load balancer. So all these setup and maintenance, hosting the website, only has to be done by the developers. Okay, two servers, then he has to set up a load balancer above it, and then publish the website. So it's not that kind of easy for developer to write the code and to publish the website in a same go. So there's a so that's the need of here that. So how DevOps comes into the picture, this is the reason for it. So in DevOps there are around 6 to 8 stacks. I'll talk about like DevOps, like in the stack, like there are version control systems like TFS, Git. I'll explain briefly each and every stack and another slide. So I'm just explaining what are the stacks. Like first I talk about the version control stack. Like you'll be knowing TFS, Git. These are just tracking your changes. So you should be know how to maintain these softwares and how these software works. Okay, next is like main in the DevOps, cloud. So cloud is very important part of DevOps. Why? So let's talk about when there is no cloud. So previously we have to deploy the code on the physical servers. So company used to buy a PC, then they has to buy a Windows Microsoft license, server license, then they have to deploy the code over it, and then the website will publish. So in this there will be a consumption of physical space. Like they have to let's suppose they're a huge organization, let's not talk about one server, let's talk about 100 server. So companies have used to allocate a lot of spaces for these servers, like a lot of workspaces. They have their physical servers, and they'll install all the they have purchased all the licenses from the Microsoft and deploy on these. So there is a lot of cost involved in it. You have to pay for the physical machines, you have to pay for the physical workspace, you have to pay for the licenses. So a lot of things involved in it. And if let's suppose that project didn't work out well, so what do you want to do? You wasted your workspace, you wasted your physical machines, you wasted your memory, RAMs, all are wasted. So no one will gonna no one gonna will pay for that. So you have to bear all the costs. So there is a need for the cloud. So you have your server. Now we talk about, there are three clouds, big players in the market: AWS, Azure, Google Cloud. So you will be having your machines, or you will say virtual machines over there in the cloud, and you will directly deploy your application over there. If you don't need it, just destroy that VM without any cost. So it will be very cheaper then. So this is the second stack. Third stack we'll talk about the monitoring tools. So once you deploy your application, you will be need to learn some of the monitoring tools like Nagios, Splunk. So this will monitor your bandwidth of that website which is hosted on the VMs. Like everything is fine. Like if there are more VMs needed for that, like traffic is increasing, you will be needing one more physical server. So it will inform you that, hey, that bandwidth is increased, just spin up one server so as to balance the traffic. So this is the monitoring tool. Fourth tool is virtualization or containerization. So in containerization, we have a Docker, which is booming Kubernetes. So I'll explain how these are very bigger tools. I'll explain how this is. So Docker is just a virtual machines. In that we can we can have our codes deployed on that. Okay. Like next stack we talk about is scripting. Like we all know PowerShell scripting and shell scripting, Python, which is widely used in the DevOps profile. Like other next stack is provisioning tools. So there is a provisioning tools named Ansible and Chef. Okay, so these are the tools. Why there is a need of these tools? So let's suppose you have 100 VMs. Okay, so it's very difficult to configure IaaS or install any required server on each and every VMs by going there. So there's a tool named Chef and Ansible. In Ansible, you'll write a YAML code, or in Chef, you just write a Ruby script. You'll mention all the servers, and you just mention in that script that, hey, this is the softwares we need to we need to install, like .NET Framework 4.5 or any other related softwares for these 100 servers. You just mention the list and just run that script. Okay, it will deploy each and everything over there. So this is about different stacks. Okay, so DevOps, like there is a comparison between DevOps and Agile. So DevOps is basically a culture and Agile is a methodology. Like in DevOps, you need to follow this culture so as to effectively release your code without any delays. Okay, in Agile is a methodology in which you need to like follow some of the things, like I'll talk about, like there will be a Scrum meetings in which there is a meeting, daily meetings known as Scrums, in which there is a discussion about how the code is going on, what are the roadblocks you are facing. Scrum calls, daily stand-ups meetings. So this is will come under Agile. So Agile and DevOps is different. DevOps is a culture and Agile is a methodology. So this is little about DevOps. So in DevOps, if we go deeper, so there are four things mainly. Okay, let's talk about continuous integration first. So continuous integration in which, like, you are writing the code. Okay, you are a developer, you're writing the code. So there is something which, like, something is needed. You just directly check in your code to the with the source control. Like in the source control, it will be having all the code in it, and you're a developer. You're checking you're making your code daily, adding new files. So you need to add these files into source control. So that is how continuous integration, meaning daily, regularly, you are continuously adding your code to that. Okay, let's talk about continuous delivery. Before that continuous delivery, there is a sub term named as continuous deployment. Okay, continuous deployment meaning that you are uh, you are making changes in the source control, and the code should go to the environment on a regular basis. That, like, if there should be no delay in that. Like anytime check-in can happen, like check-in happen. So you should not do the manual trigger of that build, because that will take a time, and sometimes developers forgot to trigger the build. Okay, so that is a continuous deployment, and you need to deploy the code to the dev or stage environment, like test environments. So for that, there is a tool, Jenkins, Azure DevOps, GitLab, that is CI/CD tools, which we'll talk about later on. And continuous delivery. So continuous delivery means that once you check in the code is deployed to the development environment, then you will release the code. That is continuous delivery. So there is a very small difference between continuous delivery and continuous deployment. Continuous deployment is the deployment of the code to the dev or test or stage environment. But continuous delivery, meaning you are releasing your code to the production once the testing is done. So that is very small difference in it, that to be noted. And let's talk about continuous testing. So once the code is deployed, like once the code is written, that is continuous integration. It's checked into the source control, then it is deployed, that is continuous deployment. So yeah, continuous deployment. Then there's a term called continuous testing. So once it is deployed in the test environment, the tester used to test regularly. Like there are changes developer used to make, uh, like uh, like 24 into 7. So the code is deploying, the website is changing, or the application is changing. So you have to test the code, that is continuous testing. Next term is continuous monitoring. So as to ensure that our website or application is running fine, we need to monitor. Like I gave you one example earlier, that if there is a need of more VMs or machines, then you have to spin up more server, so as to like balance the load on for the website so that it will not crash. So for the continuous monitoring, there are tools, various tools, Nagios, Splunk. They will give the information about that. Okay, so this is the four terminologies for the DevOps. Now why we are using DevOps? Why there is a need? So if you see in the diagram, there are customers who give the requirements to software companies, and there is a dev and test teams. So there's a gap between dev and test team, and there is to the with the operations team, because these two departments are totally different. Even some of the companies, they don't used to sit on the same floor or in the same building. So there's a gap, there's a huge lag or gap between them. So with this gap, there is a huge delay in delivering the code to the customers, because there will be errors every time, like for releasing the code. So as to reduce this code so as to reduce this gap, there is a term named as DevOps comes into the picture. Okay, so here you can see there is a cycle: deploy, test, and DevOps. So this is reducing the gap between this clearly explain how DevOps, why we need DevOps, and why it's booming up in the market now. So this is the some difference between the agile and DevOps. So DevOps is a culture, while agile is a methodology. Agile basically includes three four methodology. Okay, it includes CMMI, Scrum, and Agile. So this is the methodology, which is different methodology which companies used to follow. So basically in Agile, they will discuss about the customer requirements. What are the customer requirements? How the customer is facing the problem, and they will describe these things to the develop managers. Or management will describe these things to the developers and testing teams. So and now they'll implement this. Okay, so this is how agile works. But if we talk about the DevOps is a culture in which you have to we have to reduce the gap between all the teams. We uh, have to be very much like our communication will be very effective, and we should be knowing each and every details about how it works, how the how the code works, how the code will deploy to the different environment and various tools. So this will help in effectively delivering the code or software to the customer. So this is how DevOps works. So these are the DevOps tools overview, which I given to you already. Like I'll talk briefly. Again, version control means that if let's suppose I made a check-in today, it will be named as 1. Okay, tomorrow I am making a check-in to the same code, it will be 2. So that is tracking the code. Okay, that is tracking. Let's suppose in the check-in 2 there is a mistake or there is a bug, or I checked in wrongly. So I have to roll back that to 1 again. So that is how tracking of the history is necessary. In the Git, there are three tools: Git, TFS, and SVN. So I'll talk about all these in next sessions on briefly on these tools. Cloud, like we discussed earlier, these are the three cloud platform which we are having to have the VMs, and a lot of things we can do in this cloud. Scripting I already talked about. Let's talk about CI/CD. So continuous integration, continuous deployment, there are three tools for that. Like you have integrated your code, then you have to release your code to the different environments. So that how Jenkins comes into the picture. After this session, I'll show you briefly show you how CI/CD works with a live environment, with a live tool with Azure DevOps. Okay, so these are different tools which companies are using. Containerization, there are Dockers and Kubernetes. It is nothing but spinning up the new images, or you can say VMs, to deploy your code or to test your environment on that machines, on that images is nothing but the machines. So configuration tools or provisioning tools, we can say Ansible and Chef, which I discussed earlier. So testing, Selenium, JUnit, and other integration test. So all these testing can be integrated with the CI/CD tools. Like you deploy the after the deployment, you can test your code. Like tester will give you the script that this is a Selenium test. You just need to integrate these tools to your CI/CD. After deployment, it will test automate it will run the automated test on your code too. Monitoring tool we discussed, Nagios. It will monitor each and everything, like how the traffic on your website, like if there is a suspicious activity going on, it will log that and inform you. And the last tool which I mentioned is compilation. Actually, it should come up. So compilation means that your once you write the source code, it will be a CS proj file, so or JSON file or something like that. These file, so these file are very big in size, which cannot go to the live server. So there is a need of the compilation. Binaries should go to the server. So MS Build, Maven, and Ant. MS Build is for the .NET code. If there is a .NET code, there will be some CS proj file generated after you written the code. So that CS proj will be converted to the uh, DLLs with the help of MS Build. While if you talk about Maven, Maven is for the Java codes. So our jar file or var file should be deployed over the code, should be deployed over the server. So this is done by the Maven. It will just compile the Java application and just deploy to the Java servers. Deploy the jar var files to the uh, servers. Same likewise, and is like that way only. It's a compilation tool. We'll discuss later on. So I'll briefly talk about how DevOps is booming up now. So why we need a DevOps? We discussed already. So like earlier we are having the cloud. Earlier we are having these physical servers. So like if we don't need these servers, or like if there is anything comes up between, like failovers, disaster happen on that, so our physical servers, physical workspace, everything will be gone, and like everything, there is a data loss on that, on that cases. So cloud comes into the picture, and it will have our data, everything it will have on these clouds. Now there is a question: we are giving our data to the Azure, to the AWS. So is it secure? Yes, it is secure. There is a guarantee on that, which is claimed by these companies. Why? How? So your code will be having on 6 different environments. If we talk about Azure, so not one copy. Your code will be code will be under 6 different copies will be deployed with Azure cloud. So it's totally secure over there. So let's talk about, like, DevOps is very high demanding. And like if you search DevOps is in 2018. If you search the reports, then it is a top 10 technology which we need to run, which is booming up in the market. It's highly paid than the developers in the US. So why, who are the DevOps guys? Like there are very expertise DevOps in the field of DevOps. Who are they? Like, because DevOps comes in the picture mainly in 5 to 6 years. So like the sysadmin guys, DBAs, ITs, operational, these are the guy, because these guys know how things works. So they switch to the DevOps. They learn some technologies, they learn some tools, because it's not that kind of difficult. Like as if you want to become a full stack developer or a backend developer, it's not that kind of difficult. So if you like grab some tools of like for every stack, you will be having the knowledge of at least one tool. Okay, there are eight, nine stacks. So you need to be having knowledge of at least one tool. So once you have that, you can directly switch over your job from like DBA switching to the DevOps, sysadmin, IT, operations guys are even developers also switching to the DevOps. So this is how it's booming up in the market now. Okay, so it's a very challenging and critical role. Why? Because it's your responsibility to deploy the code, to manage the production environment. It's you only to have that all these uh, thing to be deployed on the uh, live environment. So you will be a very critical, you will be in a very critical position. So let's I'll give you a some practical and live example. So this is Azure DevOps. Okay, so this is a CI/CD tool. It's not just CI/CD. I'll show you in this how CI/CD work in this. It's not just a CI/CD. It's a lot bigger than that. Okay, if you just log in for the CI/CD, it will come like this. Okay, these are kind of project. I'll go to my this project. This is the example which I am showing you today. Okay, so this is the project, and these are the repositories. Like you must be having your repository in your physical server. So now Azure DevOps is giving like you can store your repository in here. Okay, so this is my .NET repository. See, you can see here, this is my .NET code. Okay, I just pushed my code in here. So you can add your repository, you can import repository, Git repository, or TFVC. TFVC is Microsoft's version control system, like TFVC. Like this is the TFVC project. So you can import your Git repository, or you can import your TFVC repository. Okay, so I'll show you how I'll import it. I'll show you in this only. So I'm going to my GitHub account. Let's sync this repo. So it's importing. So see, it will import everything which is here. Okay, everything which is here will come up here. So this is how we are importing here. So it's all under single go. If I go here, see, it's imported. So I can select now this one. This is my .NET code, and this is my this could be .NET code, but this is TFVC, and this is my Git repository. So what I can do is I can check in my code here. I can let's just set as test, and I'll just commit it. Okay, it got saved, and you can just check the history. So these are the history which we are having it, that I updated just now. Okay, you can see the times also here. So this thing is done by the Git in the bash. This is the bash. If you do that, this check-in, this is done by here. But with Azure DevOps, you can just import that thing, and you can just do all this activity with this UI. Okay, I had shown you this repo, how it repo works, and now we'll talk about the pipeline, which is CI/CD, which is the main thing of Azure DevOps. Okay, So I have one pipeline ready for you. I have already tested, and so this is the pipeline. Pipeline means basically you have a different tasks. Okay, you have different stages which you need to perform so as to deploy your code. As this is my .NET code. Okay, this is my .NET code. So I have added a new task. Like this. There are a lot of tasks which I'll explain you all these things in detail. This is just a briefings I'm doing here. So this is how shows up here. So we need to give each and every information here. This is a MS build plugin. Okay, let's remove this as for now. And if you go to here, so here you can specify where your SLN file is. Like here, because your code is already there in the repo. Okay, so I have already defined this, like which code you need to compile. This is the SLN file. Likewise, I said there is a solution file, csproj file, SLN. So these SLN files should be converted into the DLLs. So MS build will do that. Okay, once the compilation is done, I will publish my code. I can publish my code to the normal server, or you can say the physical server, or I can push to the Azure. This is the Azure app I am using. Okay, this is Azure app I am using, and like for this, once my DLLs is ready, I will deploy my code to here. It's up to you. You can add your Windows server also. You can just add like normal copy files, copy and build publish artifact. So you can use this tool also. If it's a physical server, you just need to mention what is your route from where the code is coming up. So you have to mention that this is my code, and this is my, like, you need to mention the artifact name, and this is how it will publish on the physical server. But in this case I'm using the Azure app. So that is on the cloud. I don't need to worry about the IS setting up or anything. I need to worry about anything. So I'll just have this app, and I'll just release the code. Okay, so deploy the code over this. So this is a test assembly like I talked about. So it will test your code once it is deployed. Okay, it will run these tests. So like this way you can add you can add n number of plugins based upon your activity. You can use Kubernetes, you can use Docker, which is required which is required by you. Okay, so once you have that, you just need to publish, or you need to just build the pipeline. Okay, so like it's I have just given very simple arguments, default argument. I didn't did any changes. Okay, I just provided very simple arguments here for test purpose. This is my subscription and all. So now you just need to queue it. I'm queuing it. Okay. So there is a agent in it. Agent meaning that uh, on which machine your code will run, on which machine the compiled code will run. Okay, so this is the hosted one, Microsoft hosted machines. You can have self-hosted too, that is the private machines. I'll show you how to configure that in the later part of the course. So this is how the code is compiling. Okay, likewise it compile, if you see that, if you saw that, likewise it compile in the Visual Studio.NET. Like .NET code compile in the Visual Studio. This is how it compiling with the MS build the same way, because the plugin is same. Okay, so once we have this code, we have to release the code. So this is CI. Okay, continuous integration, that if there is a check-in happen, the build will trigger automatically. Okay, once this happen, now comes to the CI/CD, that is release. So you need to release the code now to various environment. In this example, I have two environments. One is dev, one is production. This is this is how pipeline looks like. This is my artifacts. This is what like once we have this compiled code, our compiled code will go here. Okay, how? Like we set up in the task that once we have that code, it should go up. It should go up in the artifacts. So this is the same thing. This is the that one only. Okay. So in release, it's not doing anything. It's just copying the code to the various environments because we have already compiled code ready for it. Okay. So see, this is successful now. Okay, this is successful, and we will be having that. We'll be having that code in our release now, and we'll just go ahead and release this code. So there are a lot of variables you can do. Like it will deploy after release, it will deploy after stage. You can set up a lot of triggers in here. Each and every trigger I'll explain in the later session. So see, it is continuous deployment. Means that if there is any check-in happen or anything, it will directly deploy the code, no matter what. So let's release the code. I'm having just this so as to deploy the code to the Azure app. That's it. Nothing I'm doing, nothing, because already have the code with me, compiled code with me. I'm just releasing the code here. So it's queued. As I queued for the this only, it will started this release deployment. Let's wait for like 1 or 2 3 minutes. It will complete in that time. So this is how CI/CD works. Once you have that code, build the code. Once the code is ready, you will just release the code to the respective environment. So this is in progress. It shows like this way. See, it's deployed successfully over here. So this is how it works. So this is my application. This is my URL where my application is deployed. So with this, you can do a lot of things. Like see here, production is all also deployed. So I can restrict that because see in some scenarios you want your code should go to the dev, and then after testing and all, you then only release the code. This is how it should be. So for that, let me show you. You can set up the approvers. Okay, you can search your users, and you can just uh, put them as a approver. Once this has happened, once this build is successful, it will directly deploy to that environment too. So this is how it works. So I talked about pipelines, little repos. What are the repos we have? And let's little talk about the boards now. Like in the boards, you can create a new work items. I'll show you how to create the work items. So work item could be anything. Could be your user story, like the task which you need to do, or the bugs, or anything it could be. So this is my uh, test work item, or you can say the backlogs which I need to do. You can set up the priority, that is a top priority, and these are the things which you can set up anytime. So this is very for tracking only. You can set up these things. So all these things comes under the Azure DevOps. Okay, so this is all about the session today. Thank you.